Remember our scenario? We want to collect data from an electricity meter. This electricity meter is an external device to T-Box, but still it's part from its resources. The difference with the local I/O card is that it's not local, it is remote. And to collect data, we need to establish a communication to this device, typically Modbus transaction. So that's what we will do in this video. We will do Modbus transaction to an external device. With such a device, you receive a Modbus table with all data available in the device. I have highlighted some of those I will use in my application. Let's take a look to our hardware and how we are going to simulate this communication. I had first thought we could use the T-Box LT2 to simulate the electrical devices, but finally I have found something much easier. We will make T-Box communicate to itself. So you see here I have an RS-485 connection coming from the CPU. I will cable it to the RS-485 of the GSM card, and both ports will communicate together, because in T-Box each port are independent from each other, and each port can be master and can be slaves. So we will declare the resources of the electrical meter into T-Box. Let's go now to TwinSoft to create those Modbus transactions. As I said that T-Box would simulate the electrical meter, it means T-Box will talk to itself. So I have to declare the resources corresponding to the electrical meter inside TwinSoft. So I will make a new group. So in the list of tags, we can right-click, click tag new group, so that I don't mix up the tag of the electrical meters with the tag of the T-Box itself. So the group, I call it e-meter source, because it means this is the information, the data simulating the electrical meter itself. And then I have to declare the highlighted data here, to declare it as tag. Important information here, when we see data, it's the Modbus address here, and it's the format of the tag. So the format here is unsigned 16 bits, or unsigned 32 bits, or single 32 bits, meaning floats, or Boolean. So let's create the first tag here. So the Volt1. So it's an analog tag. I call it Volt1. The format is 16 bits, unsigned, and the Modbus address is 30,520. 30,520. Okay. Let's make the next tag. We have created the tags. Let's compare with our list. So we have word tag corresponding to unsigned 16-bit for volt. We have double word tags for current corresponding to unsigned 32 bits. We have two floats corresponding to the power for single 32 bits. And finally we have a digital 1, which is an over temperature indication. Now that the tags used for simulation are created, we will create the resources to access this data. So we go into the resources, we go into I/O, and we will add an I/O card. But this time the card is not a local card like a simulation card or a digital input or an analog input card. It's a remote module. When we click I/O cards, we see on the bottom Modbus device. So you select this item, Modbus device. We will give a name, electrical meter. So this is the device I want to access to. Its station address. Well, the station address of the T-Box is 1, and as tbox is talking to itself, we will leave it at 1. Then we select which communication port of the CPU we use. We use the communication port 2 of the CPU, the RS485, as we have seen in the displaying the hardware. Then we select trigger. A trigger is like a switch to activate, deactivate the communication. And this trigger is a digital tag. It does not exist. If a tag does not exist, I'm not obliged to go back to the list of tags to create it. I can create it from here, from this 3 dots button. I click here, I can make new tag. It's a digital tag. It's an internal variable. I call it trigger. And I will initialize this tag to 1 to activate communication systematically when the tbox starts. Okay. Okay. Now, the condition for the triggers can be positive edge or negative edge, meaning once the tag changes status, it activates the communication, or it can be on state. So because I have initialized my tag to 1, I will select high state, meaning my communication will be carried out permanently. Now in the Advanced tab, I have the possibility to monitor the communication. Well, the easiest way is to define another digital tag as communication error tag. If the communication fails, this tag will change to 1. So I click here on the button, make a new tag, digital, I call it error. I do not initialize it because it has to display the status of the communication. Okay, okay. I click OK here. My device is created. Now I will be able to define Modbus transaction associated to this device. Modbus transaction will associate tbox tags with data in the remote device. So I have to create tags in the tbox to collect data from the remote device. So we have to go to the folder tags, and I will here again create a new folder to avoid mixing up all tags. So I right click, make new group, I call it e-meter, and I can move those two tags into this folder because they are linked to those Modbus transactions. And I go into the folder. I have to create tags which have the same format that the data I want to collect in the remote device. So I open my list of data I want to collect, and I will create tags with identical format to those. So let's create the first one, which is to collect the voltage. So I will call it a EM for electrical meter volt 1. It's an internal variable. It's a 16-bit unsigned, and I select the address, for instance, 2000. You can take any address. You don't need to have a relation between the address of the tag in tbox and the address in the device. Okay, and I create the other tags. We have now created all the tags in tbox. Let's take a look to the Modbus table of the remote device. Tags in tbox, they have their own Modbus addresses. The range must not specially be the same range as in the remote device. What is important is the format. So word with word, dword with dword, float with float, bool with bool. We are now ready to create the Modbus transaction, but before we do, I would like to go back to the resources, to our remote device configuration, to discuss about the address and the communication port. In Modbus transaction, we talk to a station address as we talk to ourselves, so we have to know the station address of the tbox. Station address of the tbox is a property available in the RTU properties, and the station address is 1. Now, concerning the communication port, we have to make sure that both communication port fits. So we communicate through RS485. The source port of T-Box is COM2, so it's on the CPU, and we talk to the communication port on the GSM, which is, let's take a look here, COM0, it's COM9. So we have to make sure that of the configuration of COM9 and to have the same configuration for COM2 of the CPU. So protocol is by default Modbus, okay, and baud rate is 9600, 8 data bits, no parity, 1 stop bit. Let's check that the COM2 has the same configuration. So the COM2 is in the CPU, group 0, COM2, 9600, 8, no, 1 stop bit, protocol Modbus. Okay. Now we can start doing the Modbus transaction. Then a Modbus transaction is the association of a T-Box tag with an address in a remote device. So when I click Add a Modbus transaction, well, first I have to select the tag. So if I want to access the vault information in the remote device, I will select in T-Box the tag vault, and I have to select which operation I want to do. I want to read. From which device I select my device emitter. Which type of communication is it? So this concerns the Modbus function, and if I open the document with the Modbus table of the device, I see that I have an indication of function. So I see that this device requires function 3 to access the analog variable. So I select the type holding register, which corresponds to function 3. And then what is the address of the variable in the remote device? The address is 30,520. 30,520. So I have created one Modbus transaction to read this information into the device. Now I will create the other Modbus transaction. Modbus transactions are finished. So we have associated T-Box tag with addresses in the remote devices. Now I would like to point the configuration of the quantity. And this is very important to reduce the overhead. So to improve performance of Modbus communication, to reduce the Modbus transaction, you can work with quantity higher than 1, meaning you will transfer several data in one transaction. This requires to work with successive Modbus addresses, as well on the remote device, like here. In the remote device we have addresses in 520, 21, 22. So we have 3 successive addresses. If in T-Box the tags associated to this communication is also in successive addresses, which is the case here, I have address 2000, 2001, 2002. So it means the 3 tags, I can associate them in one transaction. So if I increase the quantity to 3, this is equivalent to reading 3 times vault 1, vault 2, vault 3. So I can delete this one, and I can delete these 2. Now if I take a look to the next transactions, the next transaction concern 32 bits variable. Modbus protocol works with 16 bits variable. So if you have to communicate to a 32 bits variable, the number of addresses to transfer will be 2. So that's why you see the addresses between variables is by 2. 28, 30, 32. But in terms of communication, when T-Box communicate to a 32 bits variable, even if you put a quantity of 1, because T-Box knows that this tag is a 32 bits, it will automatically transfer 2 addresses. So here again, if I have successive addresses, 28, 30, 32, successive, and the tag in T-Box itself, current one, 2004, 6, and 8, so they are successive. So here I can also make a block of communication. So I increase to 3 and I delete those 2. And the same for active meter. I can put it 2 because addresses are successive in the device and addresses are successive in T-Box. Be careful that when you do block communication, you cannot mix several formats in one block. You can only make blocks of 16 bits, blocks of 32 bits, blocks of floats. Now let's send that to T-Box and see the result. Okay, program has been sent. Let's take a look to our tags here. So let's display both windows. So we'll make a new window. We'll make 2 windows of tags here so that I can see both my I can see the source. So this is the value I'm reading, and in this one I read the tags that I'm reading into the source. So if first my trigger is 1, meaning I am doing communication to the device. Now if I change the volt here to 2030, so you see here, now I read it, this value. So I repeat, this simulate my meter. I communicate through the RS-485 of the GSM, and here I am in my T-Box and I read information from here. So when I change value here, I can read it back here. I have changed value on all the tags. So I remember to change a value, you press F4 and you can change the value. Another possibility is you press plus, you will increment. So you see when I press plus here, it increments here also, of course. If I press minus, it decrements. If I do this on a digital tag, it just toggles the tag. You can see here. So I simulate on my electrical meter an over temperature. Okay, let's now take a look to our hardware, how it looks like. And for this, I will reorganize. So you see here, I have my hardware. I will reorganize the windows so that we can see both at the same times. So here we are. So we see that we communicate. So I repeat, we communicate through this cable. So we communicate between the COM2 of the CPU to the COM9, which correspond to the RS-485 of the GSM. So first, if I remove the cable, so this will constitute a communication error, and I will see that effectively in my device I am in communication error. If I put the cable back, the communication will be resumed and my error disappears. Then you see the trigger here. The trigger is a switch to activate, deactivate the communication. So by default, normally you always leave this to 1. But if I stop the communication, so if I change the value 0, you see now the communication stops. I reactivate the communication. So I repeat, on a digital you press plus or minus and you just toggle the value. If I remove the cable, I see that the master will try to communicate each second. In Modbus communication, there are several timings that you can adjust in the communication port. So you go to the configuration of the source communication port, which is the COM2 in our case. So in the CPU, COM2. And in advance, I have some timing settings, and the timeout here is 1 second, is the frequency we see here in the communication. So when T-Box receives no answers, it waits 1 second. And this is what we see here. By the way, talking about LEDs for communication, Well, you can see now I communicate through the Ethernet with my PC. I don't communicate anymore through the USB, but through the Ethernet. You also have LEDs indicating the Ethernet communication. One for the link, one for the communication. On the GSM, the same. We have also LEDs indicating communication. The first one on the top is the network LED. It indicates the GSM is registered to the network. The online indicates it has received an IP address. It's connected. And then we have the transmit receive. When it communicates, we would see, or we see here sometimes a little bit flashing because the GSM communicates to the network. This ends this video about Modbus transaction to a remote device. Let's take a look now to the questionnaire. So the exercise for this video, well, in fact, you will do exactly the same as you have seen in the video. So I remind you, use always the same application in which you add new features. So first we will create the tags simulating the e-meters. So you have to create tags at those addresses with those format. So 3 tags volt, unsigned 16-bit, 3 tag currents, unsigned 32 bits, 2 tag powers, single 32 bits, and 1 tag over temperature as a boolean at those Modbus addresses. In the resources, you create a remote device, you name it e-meter, station address 1, we communicate through the RS485, you create a tag trigger, which condition will be high state, and in the advanced tab, you create a tag error. You create the tags to communicate with the e-meter, so you create a new group, you create the tags with a format corresponding to the data you want to collect in the remote device, as you can see in this column here. Make sure that the tag have successive addresses. They can be different from the addresses in the remote device, but we make them successive so that we can make block communication. Create Modbus transaction and make block of data for volt tag, for current, and for power. So you should have 4 Modbus transaction. Send the program, change the tag trigger to see activation and stop of communication, remove the cable to check the error flag indicates a communication error, send me the application, take a small video of values of tag and LED activity, and send the video also. Good luck.